My name is Charlie Fry. I'm Chief Cartographer at Esri, but one of my day jobs is to produce the basis for doing GeoEnrichment. It's a data set that we have on the GeoEnrichment server that makes the whole thing work, and so that's the reason we're going to talk a little bit about this. And with me is Mark Gilbert. He's a product engineer on my team, and he is the really my partner in crime for working on this data set. So the idea was to be able to do it faster and better every year, so it got to the point where I needed some help, and Mark has done a wonderful job in getting us moving even better every year. So one thing I want to start off by doing is finding out how many of you are using GeoEnrichment now? So most of you. How many of you use the GeoEnrichment API to do programmatic access to GeoEnrichment functionality? Nobody. We have really good help for the API though. And actually it's useful to know that, because that's how I learned most of what I've known or grown to learn about GeoEnrichment over the past few years, is that's where we have the detailed documentation for how to do things. So what is GeoEnrichment and everybody else? This is a process, and we have a number of tools that do this process throughout the ArcGIS platform. And what it does is it takes your polygons and adds attributes from demographic data sets to them and creates a new polygon data set that has those things attributed to them. And so what we're going to do today is show you a few kind of instructive demos that show how this all works, and then we'll wrap up with a few demos that expand to show some different patterns of use that you'll hopefully find useful in terms of getting more value out of GeoEnrichment. So to start things off, Mark is going to do a quick demo just to introduce the user interface for doing GeoEnrichment, and then we'll pick up some more of the how it works from there.
Great. So for our first demo this morning, I'm going to take you all the way over to Turkey. As a young person, I was fortunate to have spent some time living in Istanbul, and given the time that has passed, I thought, well, it would be interesting to know what's going on in the old neighborhood that I lived in. So in this demo, we're going to take a look at some spending data for the neighborhood that I lived in. And the two things that stuck out in my mind from that time are the food and the sheer number of people that smoked. So let's take a look at some spending data on food and tobacco. So for starters, I need some features to enrich. And I happen to know that the Living Atlas contains some postcode boundaries that I want to use. So I'm going to search the Living Atlas of the world for Turkey postcode. I can type. And that returns a set of 2017 boundaries that I'm going to add to my web map. But I don't really need to enrich the entire city of Istanbul, but I want to focus in and filter only on the neighborhood that I lived in. So I'm going to apply a filter here. Okay, that's better. So now I've got my features that I'm going to enrich, and I'll start with the enrichment process. So on each layer, you're going to see a Perform Analysis button, and under this list of options, I'm going to choose the Data Enrichment and Enrich layer. Let me move this over. So I start, step one is to ensure that the features that I want to enrich is selected. I've got that there. If you need something else, you can choose an analysis layer as you go. Step two is to add the enrichment variables that I want to look at. And I said I wanted to look at spending on food and tobacco. So this is the data browser window, and you're going to see this in all of our examples, or some form of it. And you can find variables either by searching by keyword or by browsing by category. You also notice that it defaults to Turkey in this case, because that's where I am. So let's start with food. If I search on food, here's a whole list of food and non-alcoholic beverages. Let's look at the 2017 per capita, and then let's look at tobacco. And again, let's do expenditure per capita. Now, as you notice, as I click these variables, they're getting added to this list of selected variables. And you can see that running list here. And if you need to remove any, you can do that here as well. Got my variables assigned. Step three is to define an area of enrichment. We've got polygons, so I don't need to use that now, but we're going to come back to that in a bit later. You need to give it a unique name. I'm just going to go with the default. Down here at the bottom, there's a Show Credits button, and I want to show you what that will tell you. Since enrichment does require credits, this is a handy report because it will tell you the number of records that are going to be enriched and what that will cost you in terms of credits. And so I've got 17 polygon features, and you can see it's only going to be 0.34 credits. Go ahead and click Run Analysis. This warning is just telling me that because I'm enriching a living atlas layer, it may take a little bit longer. So as Charlie described, this is going out, sending out the polygon features that I had filtered, enriching them with the variables that I selected, and it's going to return back a similar polygon feature set with those attributes added to it. Here it comes. Okay, so what I'm going to quickly do here is give it some symbology on tobacco. And here's the range on the low end, 1,200 Turkish lira up to 1,400 Turkish lira in the dark colors. And my neighborhood here, I can see that we certainly did not spend the most on tobacco that year. So here you can see it's the polygon feature, and at the bottom, unfortunately, my legend. Let me move this over just a little bit. You can't quite see what they are. There we go. My enrichment variables: food and beverage per capita and tobacco per capita. Okay, so that's our GeoEnrichment workflow.
All right, so I guess I want to give you a little bit more of an idea of what is available for GeoEnrichment. And the biggest thing is in the Living Atlas is that if you think about all the possible boundaries Mark could have chosen, he took some easy ones, but every data set in the Living Atlas is perfectly capable of providing you a context for enrichment. And the power of GeoEnrichment is it's capable of putting attributes onto any polygon. And one thing, I don't know if you noticed it, but I've used GIS for many years, and one of the things that continues to, over the last few years, kind of astound me is how easy it is to do GIS online now. So Mark didn't need to have any data of his own. He could use the Living Atlas as a gigantic hard drive of pre-curated good data sets and pick from what he found there and enrich a subset of those features, which included making a copy of the geometry and the attributes that he found and adding the new ones that came from the GeoEnrichment operation. There are a couple of sessions that are worth knowing about. If you don't know a lot about the Living Atlas, we'll give you a little bit of an introduction today here, but there's a whole session that introduces the Living Atlas. We're going to focus on the idea of demographics and people type of variables, but there are many other variables available. And then there's a road ahead session. Just kind of curious, do any of you contribute to the Living Atlas, your data? So one, couple? Good, excellent. So you have some idea about that. So that might be a good session as well. So let's go on and let's take a quick look at the Living Atlas. One of the things that is useful to know is all the data that's available to do GeoEnrichment with is also available in the Living Atlas. So if you're ever wondering about what variables are available for a given place, you can actually find that in the Living Atlas. And so we'll show you a little bit about how to do that. So one way to do that is based on the idea that every country, and we have over 130 countries that are available to use GeoEnrichment with, is available in the Living Atlas. So for instance, you can let's start with just a high level. At the very kind of far right, there's a count of the number of layers in the Living Atlas. And it's useful just to see that count relative to what you begin filtering to. So there's almost 8,000 layers. And Mark, if you click on people, that begins to give us the idea of what are available for demographics and variables and maps and data that relate to people. So if we look at population, and there's also spending and health and so on. Just to give you an idea, most of our GeoEnrichment attributes fall into three categories. We have just basic demographics, so that's age and gender cohorts and basic characteristics that most national statistic agencies collect. We also have consumer expenditure data for many countries, and then in a few countries we also have consumer or segmentation data, and that's the idea of coming up with different types of spending profiles for people who live in different areas. So in this case, let's go ahead and search for Turkey, and just to give you an idea that kind of bring full circle to the demo that Mark just showed. And what we should see here are a few standard layers for Turkey. So we see Turkey boundaries. So are you still on the people category? Yeah. So the idea is we get all the data for Turkey this way, and then if you click on people.
Oh, you want people? Sorry.
Yeah. Just go to people and population. This will narrow it down to, in particular, two there's a map image layer and a web map. And if we take a look at the map image layer, both of these contain the same data, it's just packaged differently. And this is what we have for the data we have for Turkey. And so the way to see all the attributes that are available for it is just to open it in the map viewer. And then once that loads, open the table up, and that will give you the list of attributes that are available for that country. So all the attributes are available in every level of geography. The way we build it is that we take that most detailed level, build everything for that layer, and then we dissolve into the other layers. So that way we're able to get to the same variables at every level of geography, whether it's country, region, sub-region, province, and so on. And then as you can see here in Turkey, we have it looks like age categories in 15-year increments. So depending on the National Statistics Agency, we have different variables. All right, so we'll go back to the slides here. And so the next thing I want to talk a little bit about is actually how that GeoEnrichment process works. So as you're thinking about how you are getting data and what the limitations or what the advantages of GeoEnrichment are, this should give you the strategic ability to figure that out. So what I've got here is this purple ring here representing it's just a distance polygon from where somebody might be standing, and in this case it's in Lisbon, Portugal. And so for the GeoEnrichment process, whether it's a tool in ArcGIS Online or it's in ArcGIS Pro, the idea is that we are going to need two inputs. One of them is a polygon that you can supply, or a definition that you would supply. And we'll go through some examples that show that. And then what information do you want to add to that polygon? Then what we do in the back end is that our GeoEnrichment server has all of those geographies we just showed in the Living Atlas, and it has it available just for the task of doing GeoEnrichment. So the first thing we do is we select the most detailed geographies that are available for that place. So in this case, it's some census units that are in Lisbon. And the next step is to figure out which ones are completely inside. And that's what allows us to say, okay, that's an easy calculation. For all of those, we just do a summary and figure out, if you're looking for the total population, we just add those up. But next comes the harder part, which is to take a look at the all these detailed polygons that are now in purple that intersect that purple boundary. And those are the ones we actually have to figure out something a little bit more for. And that's the proportion of population, if that's what we're enriching, that are represented there. And you can see that if you think of just saying taking the area and the percentage of area, it's not always going to be perfect, because you might have a park on the inside or a park on the outside where nobody lives. And so what we've done to get past that is to look at all places in the world using the same methodology or a very similar methodology, and we produce a 75-meter set of points for what we call settlement points. And these points have a value that represents the likelihood of settlement. We have a few places in the world where we do a little bit better than that, and I'll get into those in a little bit. But the idea is that we want to use the settlement score and figure out what proportion we want to allocate to each side of that polygon. And everything that's inside gets added to the attribute that we ultimately write in the GeoEnrichment process. All right, so once we've figured out the inside and outside and the weighting, we end up summarizing those outer polygons and then multiply them by the weighting. So that gives us a basis to know how much to add to the previous summary. All right, so one thing you might have noticed, and I'm going to say it took me a while to notice this at first, is that there are some tiny polygons in this area, because Lisbon's census data is quite detailed. And so if you notice that these little black polygons aren't in the 75-meter grid. So what we ultimately do as well is to make sure that those polygons aren't missed. We add a point to that grid for the centroid of each of those tiny census units. So that ensures everything works to allocate the total population inside of that purple ring accurately. All right, so like I said, we have a few different ways of doing these settlement points. When we started doing GeoEnrichment, particularly in the US and then Canada, we've continued to use a methodology where we take the census block points. So those are normally something that we didn't have access to as the public. We don't have the polygons for those, but we have the centroids. And we found that there was An advantage, though, if we move them to where people live. And this gets into one of the more important aspects of the premise behind GeoEnrichment, which is that we are enriching data based on where people live to do economic analysis of their spending habits and the characteristics of the population who are spending. And so we make that assumption, and so what we did when we got these census block points is we realized some of them are on airports, some of them are on chemical factories, and so on. So it's not where people live or where they spend money from. So if you were to make a polygon of people you wanted to understand better within that area, you would not expect that if your polygon went over an airport that it would get anything. And at the same time, if you moved it over slightly to include the residential areas, you wouldn't expect the census to give you an anomaly by not giving you the opportunity to include the block point that was by default over the airport. So what we did was we manually positioned those into the right places. So in addition to airports and so on, there were census block points that were out in the middle of lakes and all kinds of places that people did not live. And so we moved them to where people do live. Outside of the US, we began in 2013 to put together something we call settlement points. And what those are a combination of both remote sensing and some modeling, along with some ancillary data like road intersections. And the intention there was to figure out where people are likely to live. The good thing about that is it does a very good job of finding the footprint of human activity. But it's not as specific, say, as those block points from the standpoint that we don't know if anybody lives there. It's going to find truck stops in rural America. It's going to find, it also turns out to find irrigated agriculture really well, because what we're looking for in that model is high contrast, and then what we call it is texture. And in this texture finding model, we want to figure out where we have high texture, because that almost always corresponds to human activity. And that's usually settlement. So that does pretty good. I mean, it's been good enough in the sense that we've been using it for the last 6 years, and we've been improving that model year over year as well. And then recently we discovered that there was an even better basis to do this, and we're beginning to use this in other places, which is to take, it turned out that some countries collect address points for everybody. And it's actually a rule and a law, so to speak, that if you move within 30 days, the government has figured out where you are again, and it collects your data. When they collect these address points, one of the interesting things that we learned was that they actually make a spatial point inside of a building footprint. So this is very good at locating where people are, and this gives us an outstanding basis then to do geoenrichment. So now in Switzerland and the Netherlands, the geoenrichment process uses that kind of basis to do geoenrichment. So we're excited to see that what this is doing is increasing the accuracy that we geoenrich at in those countries, and we're beginning to pull that into other countries over the next year of development. And then we also have like I said, the GeoEnrichment API has some of our best documentation for how this process works. These slides, when they're available, will have that hyperlink in there. But if you just search for GeoEnrichment data apportionment, you'll find that topic on Google as well. All right, so what I want to show next is a little bit of how GeoEnrichment and the quality of the results can vary. I don't know if you saw it in Mark's first demonstration, but one of the fields that was returned begins to look at the method of apportionment and then the reliability. So we'll give you some clearer examples of how those are coming into play, and then we'll give you some details about how that works.
So the first demo we actually did it online in ArcGIS Online, and now I'm going to switch to Pro and show you a nearly identical enrichment process done in Pro. So this time we're going to head over to...
So your screen's not...
Oh, sorry about that.
Waking up.
That's bizarre. Let me go back to here.
Okay, desktop. So get out of the PowerPoint.
Yeah, I'm going to kill, I think somehow I got on presenter mode, which is not going to help us today. So let's go back to here. Okay, that's good. Now let me see if I can, that's not working, so get out of PowerPoint.
Just hit escape.
Escape's not working. Yeah, that's crazy.
Slideshow
Sorry
menu.
about that. There we go. I'm not sure what that's doing.
Go to the slideshow menu, make sure it actually stopped.
Yeah. Let me kill that.
So go to slideshow, is it stopped actually?
Yeah, I just killed it now. So what do we have there on the screen? Nothing on the screen.
Right click and go to display options on the desktop.
Display settings. Let me try this one. Okay, that's better. All right, sorry about that. We're going over to Poland. Let's see. And what I want to do with this example is kind of echo what Charlie was just mentioning, that there's a relationship between the size of the feature you're enriching and how GeoEnrichment actually works. So in order to demonstrate this, I've created two polygons for enrichment in Poland. One is in the Warsaw area, in more of an urban area, and then a much larger polygon covering sort of a big chunk of the northwest of rural Poland. So with these in mind, let's take a look and see if we can figure out who spends more on books, urban dwellers or rural dwellers. So here, since I have my polygons for enrichment, I'm just going to dive right into the enrich process. So on the geoprocessing pane, I'm going to search for enrich. And I do want to point out, I actually get two results. The Enrich tool, which is what I'm going to demonstrate for you, is available for all of you right now today in Pro. I have Enrich Layer because I have a business analyst license on this computer. But what I'm showing you today, you can do from your own Pro instance. Okay, now one thing I need to double check is I need to change my data set, and I know Charlie's going to talk a little bit more about what this is.
What happens when you use ArcGIS Online, it figures out pretty well when you zoom to a different country that you're in a different country and automatically sets up the country that you're going to use for GeoEnrichment. In ArcGIS Pro, we use a geoprocessing environment setting to do the same thing, and you have to explicitly manage that. Okay, so again, pretty straightforward. My polygons for enrichment, I'm just going to accept the default name. And I'm going to use this variables button. Now, one thing I do want to point out, I am currently logged into my ArcGIS Online organizational account. So this add variables browser is actually using the exact same service that I was using in ArcGIS Online. So again, you can search or you can navigate via categories. And I'm going to search on books. And let's do a 2017 books and stationery per capita. And here, you can also see it adds and operates very similar to the online version. Click OK, and I'm ready to run that.
Question is there a button to see how many credits are being consumed?
The question is there a button in the Pro user interface to see how many credits you're using? And we were looking for that and did not see it the other day. So
what it does give you,
we need to check with the team.
Yeah, I don't think it tells you specifically, and I don't know if Lucy knows, but it does warn you that this tool consumes credits.
Yeah, so there is a way to calculate it. We have a website that tells the number of credits used by GeoEnrichment per feature. So if you know your feature count, you can get a calculation from that.
So here is the output, and I'm going to go ahead and open that attribute table, and we'll look closely at what's in here. So looking at our enrichment attribute, it looks like 616 is greater than 425, and which one is that one? We can see that the urban dwellers actually spent more per capita in 2017. The other interesting item that's in here, and I know Charlie's going to address this, is under aggregation method. You notice that the smaller polygon used this block apportionment method, and the larger one used the centroids in polygon. Okay, now let me, Charlie, get back to...
Okay, so you're getting back, there was a question over here.
But does it also then generate metadata about the derived feature class that you created?
So you're asking whether you're getting metadata for the feature class that you derive, but are you looking for something specific? Because it's not going to generate the default metadata right away.
Because you're using living atlas data to
Yes.
pull that. I thought that perhaps that some of that living atlas data would then inject
Right.
something there in your derivative feature class.
No, it doesn't. So what you're really getting at is, do you get a lineage from which living atlas feature class or which living atlas data was used to give you the initial polygon geometry? Now, that's not there by default. So if you're doing this, say, for a process that needs to be documented, then you're going to want to go to the content item for that living atlas item and get its information. Sometimes there's even a citation string for that feature, so that's what you would need to do there. All right, so what Mark just showed is that there are some different apportionment methods. And so that gets into the idea that there's different bases for doing enrichment. So we talked earlier about the idea that there's some slightly different variants on the points that are used as the basis for redistribution. There's also some variants on the geometries that are used to do GeoEnrichments with. And so when we do what's called block apportionment, that's our most detailed possible way of doing GeoEnrichment. So that's named based on the block centroids that came from the US Census, but it's the same method that we're using even when we're using the settlement points, no matter how we've created settlement points. However, when you have a polygon that's really large, that potentially says we're going to pull in hundreds of thousands of features and millions of points, and that can go really slow. So what we found out is that the difference statistically is insignificant as the difference between then saying, well, let's do something smarter and take the next level of geometry up. So from census blocks and block groups, which contains the attributes, we can go up to tracts, and then we can use the centroids of the block groups instead of the blocks and come up with an answer to a larger polygon. And as you get to larger and larger polygons, we'll scale that up to make it efficient. As to how precise it is, and I say statistically insignificant, the idea there is that the margin of error between using those coarser units is going to be in the same range as the margin of error that we had already, from the standpoint that even though we have new statistics, it's still an estimate of the number of people there. So it's just we've end up taking that estimate, and it gets a little bit coarser from the standpoint of the statistical validity, but it's a fast result at that point. And so if you wanted to get a accurate, detailed large area, there's another way of doing that, and we'll show that later today with the last demo we have. And so, but the idea is you're going to break that polygon up and enrich multiple features to force smaller features to use the block apportionment method. Then one other thing to consider is tiny polygons. So I remember years ago running into a professor that I worked with, and he was literally trying to do GeoEnrichment on his backyard. And he wanted to see if it would work. So the problem with that is that if you actually get a result for your backyard, you just had the good luck of having a block point centroid wind up in your backyard. But even in where we're using the 75-meter spacing points, if you come up with a polygon that fits between those points somehow, we have no basis to do apportionment. So we don't actually return a result. So you'll notice if you try to enrich a city park somewhere, that it's not going to return anything because we don't have any settlement points or block points in the city parks. And so that's why those tiny polygons won't get any new attributes. What you would typically do differently is that you would use, say, a drive time or a travel time buffer around that location and then find out what's near. All right, so I've been talking about levels of geography, and not all countries are created equally in terms of what's available in terms of levels of geography. So depending on where you want to do GeoEnrichment, some countries are going to be much better than others. I just used the UN 2-digit codes to list off the countries that have very detailed census data that it's akin to what you'd find in the US, Australia, Canada, and so on. And all of these countries have the best bases you could imagine for GeoEnrichment, in the sense that they have detailed polygons where population density is factored in through the detailed geometry that they have. We also have data from other countries where we might not have been able to use the national statistics data because they don't release it to the public. But we've been able to work with our business partner, which in this case is almost always Michael Bauer Research. And they estimate the boundaries for very detailed postal codes. And so what happens then is that some countries may have two types of boundaries. They'll have administrative boundaries or census boundaries, and that's like what we have in the US. But we also in the US have postal codes. So depending on the analysis you want to do and depending on where the data comes from, the postal codes may provide just as good of a basis to do geoenrichment as the census data. Because all we're looking for is to figure out, where have we estimated people to be living based on the census geographies or the postal codes, and then where do we think they're located given the settlement or the block point that have been adjusted. So this gives us, I think, almost 30 countries, or a little over 30 countries. And in all of these countries, you get the best possible results for geocoding or the geoenrichment that we can provide. But we also have 100 other countries, and the results can vary. And I think I've got an example coming up here just to give you an idea. But I want to introduce that example in the context of reliability scores. So we started finding these examples and realizing we could actually quantify some expectations for how good geoenrichment can be in different countries. And so we came up with this concept of reliability scores a little over a year ago. And the idea is that we have a score from 1 to 5. And it's a kind of a theoretical maximum of 1.0 where no country actually achieves that. And then we have a theoretical minimum of 5.0 and no country is that bad either. It's the curve for all the countries we support is a normally distributed curve, so you see a lot of countries in the middle, a few countries on either end. We have a number of factors that go into an overall reliability score. So we take things like the age of the last true census or the last estimates. And this is a methodology that is actually very well informed by the UN's Population Division and how they look at reliability. We take a look at the type of census. So a de jure census, it's a de jure from the French for by law, which is the idea of where people live normally. And that's the preferred basis for how we do geoenrichment relating to demographic characteristics and their spending and people's spending habits, versus a de facto census, which is where somebody goes out and eyeballs an estimate of where people are on a given day or a given duration of days. But usually it's a short period of time, and the level of quality of the estimate is lower than a de jure census. So a de facto census or de facto survey is going to get a higher and less reliable score than a de jure census. We also look at the size of the reporting units. So, for instance, in Italy or Brazil or the US, we have very refined reporting units almost everywhere, particularly in urban areas where people live, though. But then take a country like Indonesia, where I'll show an example in a moment. We have, I think it's 13 polygons representing all of Jakarta. And so it's roughly 1 polygon per million people. It's not a very good basis to figure out specifically where people are concentrated that have certain spending habits or certain demographic characteristics. We also learn from how we calculate settlement that we have some biases that are introduced through some of our processing. So one of them is that we process this as raster data. And in raster data, we have a byproduct of processing called resampling, which is at the edges, we may or may not include a pixel. And so we know that on coastlines or at the edges of populated areas, we are potentially a little less accurate. So the more complicated and the more edges we have within a certain region, then the more we know that there's a potential for underestimation. And then last, we also look at the quality of Landsat imagery that we're using. So we curate that imagery every year, figuring out cloud-free days that are the best possible images to use around the world. So we have about 9,200 images. I have an algorithm that selects them, and then I give myself 2 days to replace the worst of them. That involves doing things that aren't available in the Landsat archive for metadata. So they don't have anything that tells you whether there's low-level ground haze, which affects a lot of particularly desert biome areas. So for instance, I think I replaced half of the images in Pakistan this year just because they were perfect images by all other characteristics, except you couldn't see anything for ground haze. And so ground haze keeps me from finding texture, and texture is the basis for locating people. So we do our best to fix all of that. So functionally, we have two scores that we provide in our GeoProcess or GeoEnrichment results. So we have that overall quality score for a country, and we have the ratio of the population to the reporting size, because that ends up being one of the things that is a quick indicator of if you get a result that is questionable. That's the first culprit in almost every case as to why you're not getting the result you might expect. The overall quality adds some context to that. All right, so this is the example we had in Lisbon. So for a, I think I had a 2-kilometer diameter circle for this, and it intersected 183 detailed polygons, 114 are inside. That means we can very heterogeneously assign the attributes and know that we're getting a good result. Then we go to the next slide, we'll go to Jakarta again. Just to show 5 polygons, I had to expand the size by 100 times, and then we don't have much differentiation on the scores for the settlement. I mean, they're all relatively high, and it looks undifferentiated. In other words, there's our ability to therefore give you a detailed accounting or presuming the heterogeneity in the underlying data doesn't work very well in those locations. All right, so next we want to shift gears and show some hopefully useful patterns that you can apply with GeoEnrichment. One of the ones that I found useful, particularly in just telling other people about GeoEnrichment. So if you have to explain to your boss what this thing is and how it does its work, this is a good way to do it. And it's just using ArcGIS Online and adding a map notes layer with one point and then telling people what's around that point.
So for this example, we're going to head over to Rome, Italy. Let me make sure I can get back to where I need to be. That's Turkey, and here is Rome. Okay, so I have a dream vacation of going to Rome, and I envision myself renting a flat that's both walking distance to a metro station as well as the Colosseum, because I'm a big tourist and I love riding public transit. So let's take a look. I'm going to try and look at the character of this neighborhood by looking at the age cohorts and education levels in that neighborhood. Again, as Charlie mentioned, I don't have a polygon, or I don't have a feature for enrichment yet, so I'm going to use the map notes layer. So I'm going to create a new map notes layer. Let's call it vacation. And on that map notes layer, I'm going to drop a sticky pin down here in this neighborhood, and I'm going to call that flat. Typing on demand is tough, and let's just change the color so we can see it. Make it a little bit larger. Okay, so I have this symbol. Now I'm ready to begin my GeoEnrichment process, because I'm actually going to use the GeoEnrichment service to define a buffer based on this point. So using the same workflow or similar workflow, my point layer is selected already. I'm going to add my variables. Let's navigate through here. Let's go to the age category, and then I'm going to keep browsing and look at all of these, and this is the one I want. I'm going to look at all the age cohorts here. And then the other one I wanted to use was education, so under education, let's look at a degree or a high school diploma. Okay, now before we skip step 3, but in this instance, I'm actually going to put something into step 3. Now, one thing of note is in order to do this walk time buffer that I'm going to show you, you need to have network routing permission in ArcGIS Online. So from the list, I'm going to select walking time, and I'm going to enter 5 minutes. I'm also going to check this return the results as bounding areas, because I actually want to see the buffer it creates. Otherwise, it just returns the attributes on a point. Unique name, we've seen this. Let's run the analysis. Okay. There's my 5-minute walk time buffer, and let's take a look at the data values that we've got in here. Actually, let's click on that pop-up. I think we'll see it better here. And if I scroll down, I'll see my age cohorts, and the largest value is actually the 60 plus, so it's a little bit older neighborhood. And I see there's roughly 2,000 folks in that area that have a degree. So yeah, sure, sounds like a good neighborhood to me. Okay, let's go back.
All right, so there are a few options to think about for input data. So we've covered things so far by taking a existing feature service or feature class. So Mark went and found one in the Living Atlas, but it could be any of the data sets that you have locally as well. We've also looked at the map notes layer now, and then this is one coming up that we're going to use the Living Atlas layer, but it's not maybe a layer that most people would expect to use. And it turns out that it gives you a really useful basis to understand where people live and what context in the world.
Okay, let me take that back. One thing I guess I should have also pointed out is we were talking about those reliability scores, and I didn't highlight them. But in the return results, you can see here's my population to polygon size ratio, and then the apportionment confidence that Charlie talked about.
Right. You can see Italy is actually 1.7, which is one of the highest reliability scores for the polygon size because they have some of the most refined geographic units.
Okay, I'm going to go back into ArcGIS Pro for this example. So I recently did some analysis work on wildfires in California, and it got me to thinking about residential homes and smoke detector usage, specifically in communities that are in or near forests. And having lived in the San Francisco Bay Area, I thought, let's take a look at Marin County, which is just over the Golden Gate Bridge, north over the Golden Gate Bridge. So let's look at Marin County and see how conscientious their residents are with using smoke detectors in their homes. So I need to figure out what areas of Marin County are forests. So how am I going to do that? Well, I know that there's a data set in the Living Atlas that's called the National Land Cover Database. So I'm going to add the NLCD data set to my map. And the NLCD data set is produced by a consortium of government agencies headed up by the USGS. And it basically classifies all the land cover in the conterminous US and Alaska, Hawaii, Puerto Rico into 20 different land cover classifications. And when it draws here, I can show you that actually 3 of these classifications here are forests. So great, this is going to be very helpful in figuring out how I find the forest area in Marin County. Now something else you need to know about this data set, it's a raster data set. There's no vector features. And I know that might sound scary to some of you, but I'm going to show you how you can work with this data set as well. Okay, for starters, I know just enough about raster data sets to be dangerous, and I know there are some tools in Pro called raster functions that will actually help me work with this data set. And there's a raster function called remap, and I'm going to use that tool on this data set. I also know that these 3 forest categories have a particular value, and it's 41, 42, and 43. So I'm going to use this remap tool to remap all of those forest areas to be a value of 9, and then everything else it's just going to make 0. So all I will be left with...
Change your input.
Sorry?
Your input.
My input, yeah. Thanks, Charlie. I need to select my data set first. I'm getting ahead of myself. I know this is a long demo. I'm trying to cut off some time. So this is going to go out and process that data set and come back with this one here. And let me turn off the original one, and you'll see that what we're left with, clicking too fast, everything here, is just the areas in black, which are the forested areas. Okay, great. So now I know where the forested areas are, but I really don't want it for the entire US. I just need it for Marin County. Since I have the boundary, I know there's another raster function that I can actually use to clip that area. So what I'm going to do is I'm going to modify or edit what I just did with the remap, and I'm going to include this clip function to clip it to only Marin. Boy, this typing is challenging for me today. That's not it. And I'm going to use that Marin County boundary as my guide. Where is my Marin? So what this is going to do is it's going to take that result and it's going to clip it down to Marin County.
So apply it.
Oh, yeah. I have to apply that. So once that updates, you'll see we now only have what's in Marin County. Okay, so now I have forest areas within Marin County, but I know that the forest doesn't just abruptly stop, and I know that people don't build homes and sort of just stop at the edge of the forest, so I really need to build in some kind of a buffer into this. And so there is another raster function that's called focal statistics, and I know that can help me build this buffer. So let's take that. I'm going to select that remap output. And what I'm going to do here is I'm going to use a circular neighborhood with a radius of 4 pixels. And really what that's going to do is for all this forest area in Marin, it's going to create a 4-pixel buffer all around it. And I'm going to use this maximum so that it outputs the 9, which was the classification that I had remapped to forest. So what I'm going to end up with is a 4-pixel buffered forested area where all the values are 9. Okay, we're almost there. So we went from a full NLCD data set down to just the forest, and then we clipped that to Marin County and we buffered it. But I'm still in a raster format. Well, there's a geoprocessing tool that will help me with that and convert the raster into a polygon. So I'm going to go over to my GeoEnrichment, or my geoprocessing, and find that tool. Raster to polygon. And my input is going to be the output that I just finished. I'm going to use the value field. I'll give it a name. Let's call this Marin County Forest. All right, and I do not want to simplify polygons. Now this seems like it's a few more steps, and all I'm trying to do is get to a polygon that I can use for enrichment, but I think it's important to show that you can work with raster data. So here we are. I have a polygon that I'm almost ready to enrich. Now what the raster to polygon tool did was it actually created 287 individual polygons, and what I really want is one single one. So I'm just going to use some vector editing tools, specifically the merge, and I'm going to merge this into one feature. Okay, I need to select all of the features in this layer. And with them selected, I'm going to run the merge. You'll see I'll go from 287 down to 1. Great. So I have my feature. I got to save that. So you'll notice it wouldn't let me continue on with enrichment, but I do need to save that edit. Okay, now I'm ready for enrichment. I've got a polygon feature set, or polygon feature like we had before. It's going to be a similar workflow. I'm going to use the enrich tool, geoprocessing tool. My input feature is going to be my Marin County Forest Buffer. I'm going to choose the default. And let's look for smoke detectors. All right, that's down here. And then let's do households also, total households. Okay, let's run that.
So one thing, well, that's coming up, it's a good practice when you're doing geo-enrichment, like what Mark was doing, is when you looked at that table and found 200 and some features there, if you enrich that, it costs a bit more in credits. So one thing to do is to either select one and enrich it to make sure you're getting the data you want, or do a merge like that, and that will let you prototype quickly to make sure you're getting what you expect.
So here is my output, and of approximately 24, almost 25,000 households in this area, only half, roughly half, are using smoke detectors. Interesting.
So I wonder where that half is.
Right. What's the next question? So this gives me great general idea about these forested area in Marin County, but I really want to know a little bit more about the pattern. Is it uniformly distributed across this area, or is it more focused? So it would be really helpful if I had a more fine grid of areas that I can enrich. And in fact, I know there is a way to do that. There's a geoprocessing tool called Generate Tessellation. And tessellation really is just a fancy word for grid. So I'm going to create a grid pattern of polygons that fit within this same area, and then I can enrich that and get a much finer detail. So I select the Generate Tessellation tool. I'm going to accept the default outline. Now my extent, I want to use my Marin County Forest buffered area to constrain it. I'm going to use hexagon, and I'm going to tell it that I want these buffers to be 1 square mile each. Okay, there's my grid over my Marin, and as you can see, it certainly extends out into the ocean and probably outside of Marin County. So I want to try and limit that a little bit. So let's see. We did select by location before, but we were going to change that, weren't we?
The clip, yeah.
The clip. So we're going to use clip on this.
Yeah, so this was a debate we had as we were building this demo, which was we can enrich these hexagons directly, but the problem is that where they intersect a forest area, not all of the hex is covered by forest. So we didn't want to make the assumption that the whole hex, just because it intersected some forest, was forested. So we decided that it would be a better, more accurate demo to clip the tessellations with the forest polygon that we generated.
So I've got my tessellated grid as my input and my clip feature as my Marin County forest buffer. So we'll clip that out. And let me turn off the inputs. Okay, so now you can sort of see that gridded area now. It's much more sort of finely tailored to that area. So I'm ready to enrich this. And since I want to enrich this new input feature with the same variables, I don't need to sort of rebuild this from scratch. I can actually reuse the previous geoprocessing step. So over here under Catalog, under History, I can right-click the Enrich step and open that up. And rather than using the Marin County Forest, I'm actually going to use my clipped tessellation. The variables are already added there for me. I give it a different name so I don't my original. Let's do grid. So that saves a couple steps. I don't have to reselect those variables.
It took me like a year of using Pro to find that history thing.
It's pretty helpful.
It's one of those things I got used to in ArcMap, and then my transition was a longer one into Pro.
And now you can actually turn those into Python script.
Yes, so we're like making Pro worth the migration.
Right, so let me symbolize that a little bit. I'm going to use unclassified color, and I'm going to do, we did smoke detectors divided by households. So let me turn off the purple, sorry about that. Okay. So we see, where'd my legend go? So the darker color indicates closer to 1, so where every household has a smoke detector. One thing we noticed that in most of these throughout this area, there's only one household. So, okay, that's probably not the best thing. So we thought, let's take a look at where there are areas with more households. So let's just do a select by location or select by attribute, and I'm going to say where the total number of households is greater than or equal to 100, just to see where the more populated areas are. And as we can see here, they're sort of that sort of coastal near the bay, and not many of these include our one household, one smoke detector per each household. So they don't appear to be very conscientious about using smoke detectors in these forested areas of Marin County. Okay.
Question is there the rating score, the accuracy score?
It's a good question. Is the rating or the accuracy score available for this result? And it is. However, this is still the rating or the reliability score for the entire U.S. Something we've also figured out and we're working on now is that we can actually give you a tailored reliability score for every GeoEnrichment polygon. And so that's on the development agenda coming up for the next year. And it was just one of these things that we realized that you would get a wildly different result for the polygon sizes in rural areas, which tend to be larger, versus the dense urban areas, which tend to be quite small polygons, and the level of accuracy, as your enrichment polygon gets a little larger, gets to be quite good. So. That gets through the examples that we wanted to show today. So that gridded example should give you some ideas for how you can break things apart and come up with some interesting managed workflows for putting attributes into useful states. And thank you very much. And if there are any other questions, we're glad to take them.
So I do a lot of scripting with this, where I'm in Pro, some canned Python scripts that will refresh population for school districts or higher districts. Is that, for scripting, is that the best route to go kind of within building a script tool or so within Pro? Or you mentioned this API. Is there a way closer to ArcGIS Online?
Okay, so that's a good question. So there are different ways of automating, and so what you're asking is, you're using scripting in Pro to automate a process year over year to see what changes. In Pro, the Python scripting is the best route to go because it's already built into Pro. The GeoEnrichment API is a REST API, so that's going to work with ArcGIS Online and feature services and feature classes. The ArcGIS API makes that pretty much an equivalent task. The older REST API involved a little bit more programming and working at lower levels of minutia, so it was a little more onerous to do, but the ArcGIS API, I think, makes it pretty close to equivalent task, so it's just a matter of where do you prefer to work? Do you want to be in Pro and desktop, or do you want to be online?
Also, can you expose historic data, say 2010 census, or even further back?
That's another good question. So can you have access to historic data? And actually a lot of people have been asking that question over the last couple of years. And so there's a short version of how to get to that today, and then that's actually something we need to do better at in terms of making other services available in the GeoEnrichment server. Today, if you have a business analyst license and you have also decided that you want local data as an option, so with the business analyst in the US, you can also request that you get the data to run on premises. With that option, you get a new capability in Pro, and we added it at 2.4, which is called a statistical data collection, which means that you can bring in any enrichment data, any data you want to use to enrich with. So if you had 2010 data or 2000 data, you could bring that data in, and then it would actually show up in the variables that you would select to do GeoEnrichment with. So it's like your ability to expand what's available in GeoEnrichment occurs because of these statistical data collections, but it does require a business analyst license and to license the local data.
Again, the historical data is coming from Esri.
It ultimately would be coming from Esri or wherever you want to get it. So you could get it from the Census Bureau directly, or whatever historical collection you have, or we have for that matter. All right, well, thank you very much. Enjoyed the opportunity to speak to you today.
Thank you.